Okay, so this is the 2024 Higher Level Maths Leaving Cert Paper 1, question 9. So let's look at part A. We have a sphere and it has radius r units. And let's see, the part of the sphere that is cut off by a flat surface is called a cap. And it has volume c is equal to pi k squared over 3 times 3r minus k. Here c is the volume of the cap, k is the height of the cap where k is between 0 and r. Find the value of c, the volume of the cap when r is 13 and k is 4. Give your answer in terms of pi. Okay, so this is just straightforward. We just write down the formula, stick in the numbers that were given, and that should get us there. So let's see, we have, I might do it in here. Let's see, we have c is equal to pi k squared over 3 times r minus k. So find the value of c. So we've got to work out c, so it's going to be pi. Give your answer in terms of pi, so we've got to leave pi there. K is 4, which we've got squared, so that's going to give us 16, and we've got 3 on the bottom. We have 3 times r is 13, so subtract k, which is 4. So that's really it. You just got to multiply all that out, leave pi in the answer, and you should end up with 560 over 3 pi, and the units are just units. So it's volume, so it's going to be units cubed. Okay, that's part 1. So part 2 here, or part B here, is, let's see, a different sphere has radius 8 units with a cap of height y units. Y is between 0 and 8. The volume of this cap is 36 pi y units squared. Use this in the expression for c above to show that y over 3 times 24 minus y is equal to 36. Okay, so let's just write down what we were given up above first of all. So we were given that c is equal to pi k squared over 3 times 3 or minus k. Now let's just stick in what we were given. So we're told that the volume of the cap is 36 pi y. So 36 pi y is on this side. Pi is pi. K in this case is y, which we've got a square, and then 3 is down here. We've got 3 times r, which is the radius, and in this case the radius is 8. And then we've got to subtract k here, which is again y. So this is it. Let's see if we can just get rid of a few things here. We've got a pi on this side, which is multiplied, a pi on this side, which is multiplied, so we can just divide across by pi. We need a y over 3, so I need this here. However, I don't need the y squared, but look, there's a y on this side which we can divide by. There's a y on this side, which is two y's, actually y squared on this side, so we can get rid of one of them. And that'll give us our y over 3. 3/8 are 24, which we need. And then we've got our minus y, so that's really it. So we do end up with y over 3 times 24 minus y is equal to 36. And that's it. That's all we've got to do there. Multiply out and solve y over 3. Okay, so you've just got to write down y over 3 times 24 minus y is equal to 36. So we've got to multiply all this out and solve it. So the first thing I'm probably going to do is multiply across by 3. So that'll give me y times 24 minus y is equal to 3 6 is 18, 1 3 is 9, 1 10, 108. Multiply out the brackets then. We've got 24y minus y squared is equal to 108. This is a quadratic, so let's bring everything over to one side. So I'm going to put it on this side. Y squared minus 24y plus 108 is equal to 0. So I just brought the 108 over and then changed the sign because that's what I'm doing to these two. Okay, so this is what we've got to solve. We have y squared minus 24y plus 108 is equal to 0. So we can do our factorizing. We've got y, 108. Let's see, we've got 108. We can go 1 times 108. We can go 2 times 54. We can go 3 times 36. None of these are going to give us a 24 yet. Let's see, 4 times 27 is close, but still no 24. And we can go 5, won't go in. We can go 6 times 18. That'll give us 24. So we can put 18 here. We can go 6 here. We need a plus, so it's going to be minus minus. So that'll give us, let's see, y is equal to 18 or 6. Now let's just see, it says multiply out and solve to find the height, so just one height I would imagine. Let me just see. Yeah, y is between 0 and 8. Y has to be between 0 and 8. So the answer then, the answer is y is equal to 6. And we are talking about units. Okay, that's it. Let's have a look at the next one. A hemisphere has a diameter of x, v of x. The volume of this hemisphere in centimeters cubed is given by that thing there. Find the value of x when the volume of the hemisphere is 3 liters. Give your answer correct to 1 decimal place. Okay, so we have v of x is equal to pi over 12x cubed. And we're told that the volume, find the value of x when the volume of the hemisphere is 3 liters. So here we put in the 3 liters. We're dealing in centimeters, so it's going to be 3,000 milliliters or centimeters cubed. Remember, 1 liter is 1,000 milliliters, and each milliliter is 1 centimeter cubed. So we've got 3,000 centimeters cubed is equal to pi over 12, and it's x cubed. We've got to work out the value for x. So first thing you do is multiply across by 12. So 3 12 is 36,000. Now we've got to divide by pi. That'll give us our x cubed. And then finally the x then is going to be the cubed root of this. So it's going to be the cubed root of 36,000 over pi, and that is, well, you can just do that on your calculator. We need it to 1 decimal place, so it's going to be 22.5, and this time we do have units, it's going to be centimeters, and this is an x, so it's just centimeters. Yeah, that's to 1 decimal place. Okay, so let's work on D then. The volume of the hemisphere is increasing at a rate of 450 cubic centimeters per second. Find the rate at which the diameter x of the hemisphere is increasing with respect to time. When x is 20 centimeters, give your answer in centimeters per second, correct 1 decimal place. The volume of the hemisphere is v of x equal to pi over 12x cubed. Okay, so this is a rate of change type of question involving the chain rule. So let's just write down what we have first. So the volume of the hemisphere is increasing at a constant rate of, so the volume is increasing at a rate of is dv dt, and it is 450 cubic centimeters per second. So we have dv dt. Find the rate at which the diameter x of the hemisphere is increasing. So what we want is dx dt. That's the rate at which x is increasing. Now that's going to be, we're going to have dx here and dt here, and we've got to just work out what we're going to put here. But if you look here, we've got a v here, we've got a dv dt. So if we put a dv there, we have this, we have our dv dt, so we've got to put a dv here, so it'll cancel if you like to give us our dx dt. Okay, so we need to find this. We know what this is, it's 450. We just got to work out what this thing here is, v and x. But they give us a formula here. They tell us that v of x is equal to pi over 12x cubed. So we can do dv, we can differentiate v with respect to x. And we just got to flip it upside down, then our answer upside down to give us dx dv. So let's see, we bring the 3 down, multiply it by pi over 12, and then reduce the power by 1. So it's going to be 3 over 12 pi x squared, which is just 1 over 4, or just pi over 4 x squared, 3 into 12, 4 times. So now we have this here. So our answer then is going to be, remember we got to flip this upside down. This is pi x squared over 4. So we've got to flip that upside down. It's going to be 1 over pi over 4x squared. Got to multiply that by 450. Okay, so that's our dx dt, but what we've got to do is work that out when x is equal to 20. So when x is equal to 20 centimeters, dx dt is equal to 450 on the top, and on the bottom we have pi over 4 times x squared, which is 20 squared. And we've just got to work this out to 1 decimal place. So you can just do this on your calculator and you should get an answer to 1 decimal place of 1.4, and this is dx dt, so this is centimeters per second. X is the rate at which the diameter x, so x is a diameter, it's a distance, so it's in centimeters per second, 1.4 centimeters per second. Okay, so that's that one done. Let's have a look at the next part, part E. So we have a cone here. It has radius of r centimeters and height h centimeters. The curved surface area of the cone S can be written as S equal to pi r squared root r squared plus h squared. Rearrange this to write h in terms of S, r, and pi. Give your answer to look like that. Okay, so we have S is equal to pi times r times the square root of r squared plus h squared. We've got to get h on its own. Rearrange to write h in terms of the others. So let's see. We can take the S divided by pi r. That'll give us the square root of r squared plus h squared. We can square both sides, so we've got s squared over pi squared times r squared is equal to r squared plus h squared. Okay, let's just get the h on its own then. So that's s squared over pi squared r squared minus r squared is equal to h squared. Now let's just turn that into one fraction on the left hand side. Common denominator is pi squared r squared. That'll give us s squared, and then this is over 1. So what do you do to 1 to turn it into this? You multiply it by pi squared r squared. So multiply this by pi squared r squared. So that'll give me pi squared r squared times r squared is r to the power of 4. H squared. So now we've got to square root both sides. So let's just square root the left hand side, and that'll give us h. So it's s squared minus pi squared r to the power of 4 over pi squared r squared. Now we can split up that fraction. So we can square root the top to give us s squared minus pi squared r to the power of 4. And on the bottom, because these two are multiplied, we can just square root them individually. So it's pi times r. Now that's about it. Let's just see, does that look like what they wanted? They wanted the square root of s squared minus ar to the power of n. So we have s squared minus ar to the power of something, where a, b, and n are constants. So this is a constant here, that's fine. 4 is a constant, that's fine. On the bottom part of the fraction we needed br, so we have a b times r, so this is a constant times r, and let's see what else we needed. Oh, that was it. So that's really our answer. Okay, so that's really it. That's it for this question.